Hello, Algebra 2 students. On Friday in class, we started lesson 2.4, and we spent a lot of time working on point-slope and slope-intercept form. And as you can see at the top of what I have showing on the screen here, there's some example of going to point-slope. If you remember, point-slope was that y minus y1 equals m times x minus x1. And then we also, over to the right, practice slope-intercept form, which is your y equals mx plus b. At the very end of class, I talked about standard form. And I think my morning class, we only did example A. I think my afternoon class, we did example A and B. So I want to talk about B a little bit, but remember standard form, ax plus by equals c, right over here. And the idea is that x and y both have to be on the same side, and those x and y terms are separated from the constant term, and there are no fractions or decimals in the entire problem. So in example A, we had a fraction with a denominator of 4, so we multiplied by 4. On example B, there's a decimal. And you'll notice there is one decimal spot at most in any of the numbers, which is the tenths position. And so in order to get rid of the tenths position, we are going to multiply both sides of the equation by 10. So in order to remove the decimal on the right, we multiply by 10, which means if you multiply on the right by 10, we're going to multiply on the left by 10. So on the left, 10 times y is 10y equals, on the right, we're going to take that 10 and we're going to have to distribute it to both pieces. 10 times 9.1x is going to be 91x, plus 10 times 3.6 is going to be 36. At this point, our job is to get x and y on the same side. You could go about it a couple of different ways. Because I already have the y on the left by itself, I'm going to take the x over to join it, which since it's a positive 91x, I'm going to subtract 91x. If I subtract 91x on one side, we're going to subtract it on the other side. And so trying to get in that xy form, I'm going to put negative 91x plus 10y, because it's positive, equals 36. The way this book does things, that is one possible answer. Now, some books will say that you're not allowed to have a negative out front of the x term. And so if that's the case, the other possible answer would mean we go through and multiply everybody by negative 1, which basically changes each of the signs and makes it 91x minus 10y equals negative 36. I am okay with either of these answers, and if I recall, I think even MathExcel is okay with either of these answers. Okay, so A was an example we multiplied by 4. B is an example we multiplied by 10. I'm not going to take time to work through C because I don't want to make this video too long, but if we want to talk about it real quick, C, there's a fraction. How do we get rid of that denominator of 5? Well, we would want to multiply by 5. You're welcome to work that one out if you want. But I'm going to go ahead and move on to the next page for right now. On the next page, we have two other topics in this lesson. And the first topic is graphing equations using x and y intercepts. So when we talk about x and y intercepts, if you recall, we are talking about where the graph crosses the x and y axis. And I'm going to write that up here. It's where the graph crosses x, and y axis. Okay, that's what we mean by x and y intercepts, is where we cross the x and y axis. Now, if you think about where we cross the x and y axis, those ordered pairs always involve one specific number, and that is a 0. So anytime I ask you or someone asks you to find intercepts, you want to think about your zeros. So in order to find the x-intercept, we're going to put 0 in for the other variable. So we're going to put 0 in for y. So that's the first thing I'm going to demonstrate up here. So I'm going to say 3x plus 5 times 0 equals 15. Well, 5 times 0 is 0. So that leaves us with 3x equals 15. divide by 3, and x is 5. So what this is saying is that our x-intercept, where we cross the x-axis, is going to be at 5. Or if you want an ordered pair, 5, 0. And that's because we put 0 in for y. Now, to get the other intercept, first we put 0 in for y and found x. Can you guess what we're going to do next? This time we're going to put 0 in for x and find y. So 3 times 0 plus 5y equals 15. 3 times 0 is 0. 5y equals 15. If you divide by 5, y is 3. So then 3 is our y-intercept. As an ordered pair, remember we put 0 in for x. So it's 0, 3. And so if you're asked to now graph this, I'll sketch a graph. I'm only going to sketch quadrant 1 because that's all we really need here. Remember, x-axis is horizontal, y-axis is vertical. We have a point at 5, 0. 1, 2, 3, 4, 5. So there we have our y-intercept, or excuse me, our x-intercept at 5. We have a point at 0, 3. 1, 2, 3. That is our y-intercept at 3. The equation then, or the line, just goes through the 2 points as such. And that's how you graph using x and y intercepts. So if you have an equation like what we did where it's in standard form, that's the best way, or a really easy way to graph it, is to put 0 in for each variable, and you're finding the x and y intercepts. To conserve time, I'm not doing all of these, but I will say let's go ahead and practice with b. I think it would be a good one to practice with. So b this time, 2x minus 4y equals 8. We want to find our x and y intercepts. So ask yourself, how do I find the x-intercept? How do I find what x is? We're going to put 0 in for y. So 2x minus 4 times 0 equals 8. 4 times 0 is 0. So 2x equals 8. Divide by 2, and x is 4. Be aware of what that is as an ordered pair. X is 4. We put 0 in for y. So as an ordered pair, that is 4, 0. And that is my x-intercept. Now to find the y-intercept, we want to know what y is. So we put 0 in for x. 2 times 0 minus 4y equals 8. 2 times 0 is 0. Notice this 4y is a minus or negative 4y equals 8. Divide by negative 4. And 8 divided by negative 4 is negative 2. So we have the ordered pair 0, negative 2. Okay, so just watch out remember if there's a minus sign in front of a term, that goes along with it as a negative. If I sketch a quick graph here, x-axis is horizontal, y-axis is vertical. We have an x-intercept at 4, 0. 1, 2, 3, 4. And we have a y-intercept at 0, negative 2. 1, 2. That is 2 down. And so this time, our line goes at a different angle because we have a negative intercept involved. Okay, so it's a really easy way to forget, but it's a really easy way to work. So x and y intercepts, just put in your head, x and y intercepts, zeros. That's what you have to work with, okay? So I'm going to skip down to our next topic. I guess if you want to know on C, I can tell you that you end up with an x-intercept of negative 2 and a y-intercept of negative 3/2. So in case you want that information, you have it. Okay. The bottom part of this page is parallel and perpendicular lines. And just being able to write an equation. Now, good news, this goes right along with what we did on the front side of the notes in class on Friday. Okay? So, and if you missed class on Friday and didn't get those notes, you can always go copy the notes from my notes in the classroom. But parallel perpendicular lines. So as we look at the first one, first of all, notice the directions. It's wanting it in slope-intercept form. So if it wants it in slope-intercept form, do you remember what that is? Y equals mx plus b is going to be our final form. Now, if you recall what I taught on Friday, though, I'm always going to start us with point-slope form. Okay, so example A says we want to write an equation parallel to y equals 6x minus 2 through the point 1, negative 3. So first of all, big thing is we have to know what it means for lines to be parallel. And parallel lines have what kind of slopes? They have the same slope. So if you know the slope of one line, you know the slope of its parallel line. So right there, big deal. Parallel lines, same slopes. Now, as we look at the given line, can you tell me the slope? And you should be able to, because notice it's in y equals mx plus b form. And so this means the slope of the given line is right there. Slope is 6. M is 6. So that's the slope we're going to use on this problem. That minus 2 in the equation means nothing. It's just extra information we're not going to use. Because then the other piece of information we're given is an ordered pair. So we're going to use the slope of the parallel line, so 6. And then we're going to use the point 1, negative 3. Remember, an ordered pair, it is xy. And we're going to write our equation using that point and that slope, which is one of the skills we did on the front side of the notes if you want to flip back and look. Now, again, remember, I'm going to teach us to start with point slope. I'll write it out here. Y minus y1 equals m times x minus x1. So with that in mind, y minus, remember for y1, you're filling in your y coordinate. In fact, these coordinates you can think of are x1 and y1. So it's going to be y minus negative 3 equals m. We have our slope of 6 times x minus the x coordinate, which is 1. Our goal is to get it to slope-intercept form, so y equals mx plus b form. So let's do some cleanup. First of all, don't forget y minus negative 3 is really equivalent to y plus 3. And then on the right, we need to take that 6 and we need to distribute. 6 times x is 6x, minus 6 times 1 is 6. We need this to be y equals, so if it's y plus 3, we now are going to subtract 3. What we do on the left, we do on the right. So now on the left, our 3's will cancel. Y equals, and we have 6x minus 6 minus 3. That's like negative 6 minus 3, which is minus 9. So we end up with the equation y equals 6x minus 9. Okay? And that takes us to B. I want to at least do a perpendicular example, which is what B gives us. So B is, the line is perpendicular to y equals negative 4x plus 2/3 through the point 8, 5. So, perpendicular, okay, parallel lines have same slopes. Perpendicular lines, opposite, reciprocal slopes is what I say. Okay, so perpendicular lines are always opposite reciprocal. Opposite meaning opposite of positive or negative, so the opposite sign. Reciprocal meaning flip the fraction upside down. So let's look at our given information here. First of all, we're given the equation y equals negative 4x plus 2/3. Notice it's in y equals mx plus b form. So the given slope is m equals negative 4. If it was parallel, we would use that. But it's not parallel. In this case, it's perpendicular. Opposite, reciprocal. So first of all, what is negative 4 as a fraction? That itself is negative 4 over 1. So the perpendicular slope, opposite of negative is positive. Reciprocal of 4 over 1 is 1 over 4. So the slope we're going to use in this problem is positive 1/4. That fraction of 2/3 that might have had you freaking out that I was giving you a fraction, that doesn't matter. Okay, we don't care what the initial y-intercept was. And then we're going to use the given point, 8, 5. Remember that is your xy coordinates. If you want, you can think about as x1, y1. Again, I'm going to encourage you to start with point slope. Y minus y1 equals m times x minus x1. So y minus y coordinate of 5 equals m, which is 1/4, times x minus the x coordinate of 8. Okay, work on cleaning it up, distribute, and make it y equals. So first of all, I'm going to take the 1/4 and distribute. So still y minus 5 equals 1/4 times x is 1/4 x minus, what is 1/4 of 8? And 1/4 of 8 is 2. If you prefer, bring it off to the side and think what is 1 over 4 times 8 over 1 as a fraction. So you can say 8/4, which is 2. Okay? Now, almost there. We have y minus 5. We need to add 5. So, minus 5 plus 5 cancels. Y equals, which was our whole goal, 1/4 x, negative 2 plus 5. Opposite sign, so subtract, go with the sign of the larger value, and it's a positive 3. So I end up with y equals 1/4 x plus 3. Okay, so just like what you're doing on the front, using the given point and slope. They give you the point, you just had to find the slope, and that's looking at the slope of the given line. So either parallel or perpendicular, depending on the situation. Okay, my video is at just shy of 20 minutes. And so I think I'm going to call that a stop there. Okay, I don't want you to have too long of a video because I want you also to have time to work on homework. And so, as you know, your homework is in Math Excel, lesson 2.4, and that's what you need to spend the rest of the period working on. When I come back and we get in class on Wednesday, you should have lesson 2.4 done and just ready to answer or ask any lingering questions. So make sure you've worked through it. I don't mind answering questions, but make sure you've done the homework. Okay, I want to make sure you've used your time while I'm out of class on Tuesday. So I hope you guys have a good Tuesday, and I will see you on Wednesday.